So coming to the next topic, auto transformers. So this auto transformer is also called as a single phase variac, or if it is a three phase variac, and another name for auto transformer is dimmer stat. As we have seen, while we are conducting open circuit test and short circuit test and Sumner test, and on a single phase transformer we are applying a variable AC voltage. Wherever we require variable AC voltage for starting of transformers, and starting of three phase induction motors, we can use for starting of three phase synchronous motors also. So we will use single phase variac. Variac means variable AC supply. In order to get the variable AC supply, we can use auto transformer. And coming to the auto transformer types, step up auto transformer, step down auto transformer. In an auto transformer we are having only one winding, and that is a laminated and magnetic core, while in two winding transformer we are having two windings, primary winding and secondary winding. The primary winding and secondary winding both are electrically isolated but magnetically coupled. If you go for the two winding transformer, so this is the transformer, primary is connected like this, secondary on another limb. There is no physical connection with the primary and secondary winding. Coming to the auto transformer, we are having only single winding. So here this we can treat as a primary winding, and this we can treat as a secondary winding. We can call it as a step up auto transformer, and this one is step down auto transformer. So how the current will be distributed? The input voltage is V1 and input current is I1, and the output voltage is V2 and the current is I2, and this is I2 minus I1 is in the upward direction. If you apply the KCL at this point, I1 is coming like this and I2 is going like this. So most of the students, they have got it out. Sorry, I1 is coming, I2 is outgoing, I1 minus I2 is in downward direction. No, not like that. Why? Because so if we have a more number of turns on the primary side, this I1 is less. Voltage is high, means the current is less, and the I2 for a step down auto transformer, the I2 value is more because V2 is less. Then we are getting from higher current minus lower current. That means I2 minus I1 is in upward direction. Coming to step up auto transformer, this is the I1 very high and the V1 is low here, and I2 is low and the V2 is high. That's why here if you apply I1 minus I2 is in the downward direction. So now coming to the single phase auto transformer, that means step down auto transformer. We are having a single winding. So the input voltage is V1, the input current is I1. So you are taking output, the output voltage is V2 and the current which is flowing is I2. Now this one is I2 minus I1 is in the upward direction. So the total number of turns will be N1 and this will be N2. Secondary number of turns will be N2. This is now N1 minus N2. Let us say A, B, C. AC section has N1 minus N2 turns. The total voltage is V1 and the output voltage is V2, and here how much voltage is applied is V1 minus V2. So we are having two actions. One is called the conduction process because between the primary and secondary winding we are having direct physical connection, and we are having a transformed VA also. That means volt amperes is also transformed by induction process. Let's say the MMF in AC section is transferred to MMF in BC section. The MMF in base AC section is N1 minus N2. The current which is flowing in an AC section is I1. MMF in BC section is, this is N2 and this is I2 minus A1. So N, expand this one, N1 I1 minus N2 I1, that should be equal to N2 I2 minus N2 into I1, and these two are cancelled. Now the primary MMF is equal to secondary MMF. So from this we can write it as N2 by N1 is equal to I1 by I2. And the volt ampere in AC section should be transferred through induction. Volt ampere in AC section should be transferred to volt ampere in BC section. So what is the voltage which is appeared in AC section is V1 minus V2. The current is I1. So V1 minus V2 into I1, V1 minus V2 into I1, that should be equal to the output voltage is V2 and the current is I2 minus I1. V2 into I2 minus I1. So V2 I2 minus V2 into I1 and V1 I1 minus V2 into I1. So these two are cancelled. From this V1 I1 is equal to input volt ampere of auto transformer should be equal to output volt ampere of the auto transformer. So from this I got it as V2 by V1 is equal to I1 by I2. So we are already derived what is I1 by I2 is equal to N2 divided by N1. N2 divided by N1 is equal to K, where K is called the auto transformer transformation ratio. Auto transformer transformation ratio. So now MMF is transferred through induction is equal to, so V1 minus V2 into I1. So V1 I1 minus V2 into I1. So we know that from this transformation ratio V2 is equal to K times of V1. Substitute here V1 I1 minus K times of V1 I1. So 1 minus K times of V1 I1. So this is power transformed in an auto transformer is equal to 1 minus K times of input power of auto transformer. This is very, very important. Then the total power, input power of auto transformer is V1 I1. From this, if we subtract the power transformed, then I will get the power conducted. So power conducted in an auto transformer should be equal to total input power of auto transformer minus power transformed. So V1 I1 minus 1 minus K times of V1 I1. So from this V1 I1 minus V1 I1 plus K times of V1 I1, and this will be cancelled, and the power transformed in an auto transformer in an auto transformer is equal to K times of input power of auto transformer. So this is very important. So after that, we should know the weight of auto transformer. Weight of auto transformer, and we are comparing with the two winding transformer. This is a two winding transformer diagram. It consists of N1 number of turns, and the current which is flowing through the primary winding is I1, and this one is N2, and the current flows through load is I2. And the weight of the auto transformer or weight of the any transformer will define the or decided by the MMF. So if you go for the auto transformer, so this is total is N1, this is N1 minus N2, this is N2, the current which is I1, this one is I2 minus I1. So N1 minus N2 into I1 plus on the secondary side N2 into I2 minus I1. Coming to the two winding transformer, so N1 I1 plus N2 into I2. This is weight of the transformer, two winding transformer. So now we will define the ratio weight of auto transformer. We are comparing with two winding transformer, that's it. Weight of auto transformer divided by weight of two winding transformer is equal to N1 minus N2 into I1 plus N2 into I2 minus I1 divided by N1 I1 plus N2 I2. We know that N1 I1 is equal to N2 into I2. So expand this, N1 I1 minus N2 I1 plus N2 I2 minus N2 I1 divided by 2 times of N1 into I1. So these two are equal, then 2 N1 I1 minus 2 N2 I1 divided by 2 into N1 I1. So this will be cancelled, 1 minus N2 divided by N1, that should be equal to 1 minus K. So weight of the auto transformer, is equal to 1 minus K times of weight of two winding transformer. So if how much copper is saved, suppose if K value is 0.5, weight of the auto transformer is 50% of two winding transformer. If K value is 0.9, then only 10% of two winding transformer only. That depends upon K. The K. So how much copper is saved? Suppose single phase transformer weight will be, two winding transformer weight will be kg, that means 1000 grams, and weight of the auto transformer with the same kV rating is 500 grams. How much copper is saved now? Only 500 grams, right? 1000 grams minus 500 grams will give the 500 grams. Similarly, saving of copper is equal to weight of the two winding transformer minus, if we subtract the weight of auto transformer, then I will get the saving of copper. So weight of two winding transformer will be how much? Yes, weight of two winding transformer, minus 1 minus K times of weight of two winding transformer. So 1 will be cancelled now, then K times of weight of 2 winding transformer. So that is saving of copper. If K value is 0.5, 50%. If the K value is 0.1, 10%. The K value is 0.9, so 90% of the copper will be saved. So this is a saving of copper. So with respect to winding transformer. The last one is kVA rating of auto transformer with 2 winding transformer. We are going for the comparison. The kVA rating of auto transformer, his input is V1 I1, that should be equal to V2 into I2. But in this auto transformer, the transformed A is, so kVA rating of single phase transformer, that means 2 winding transformer, is equal to V1 minus V2 into I1. So kVA rating of auto by kVA rating of 2 winding transformer V1 I1 minus V2 into I1, that should be equal to V1 I1 minus divided by V1 I1 minus V2 into I1. So from this we are getting V1 I1 is taken as a common, 1 minus V2 by V1, that should be equal to 1 minus 1 by K. This is very, very important. kVA rating of auto transformer is equal to 1 by 1 minus K times of kVA rating of 2 winding transformer. These are all, there are only 3 steps you have to remember. So first one is power transformed is 1 minus K, and the power conducted is K times. And the second one is we are going for the derivation of saving of copper. And third one we are comparing kVA rating of transformer. Auto transformer should be equal to with 2 winding transformer. And one more thing, all these derivations is for the step down auto transformer. Suppose if he asks for step up auto transformer where K is replaced with 1 by K, then you will get all the values. So power transformed is also 1 by K, and power conducted is also where K is replaced with 1 by K, that is for step up transformer. And here also saving of copper is 1 by K for step up transformer. This is for step down transformer. The kVA rating is also 1 by 1 minus 1 by K. This is for step up auto transformer.